For the first time since scientists started listening in 1982, Mount Adams shook 6 times in a single month. The largest active volcano in Washington normally sits quiet for years, one small quake every 2 or 3. Then, in September of 2024, it broke its own record. Here is the part that should bother you. The whole mountain, all 12,000 feet of it, was being watched by exactly one monitoring station. And that single station could not tell anyone whether this was nothing or the start of something. Those 6 earthquakes ranged from magnitude 0.9 to magnitude 2.0. Not one of them was felt at the surface. Nobody in the valley below woke up. No windows rattled in the town of Trout Lake, 14 miles south of the summit, where 672 people live on ground that a volcanic mudflow buried 6,000 years ago. The one monitoring station sat 7 miles southwest of the peak, too far away to say how deep the quakes were, too far to say exactly where they came from. All it could report was that something under the biggest volcano in the state had started moving in a way it had not moved in 42 years. And this is the detail everyone missed. The thing that worries the scientists at Mount Adams is not an eruption. It is a slab of weak rock near the summit that can come down on its own, with no eruption at all, and reach that town of 672 people in about 20 minutes. Go back to 1982. That was the year the Pacific Northwest Seismic Network and the United States Geological Survey started keeping a formal record of what Mount Adams was doing underground. And for the next 42 years, the answer was almost nothing. Mount Adams is not Mount St. Helens. It does not put on a show. On a normal timeline, the whole mountain produces about 1 earthquake they can pin down every 2 to 3 years. You could go most of a decade and count the events on one hand. That is what makes September of 2024 stand out. 6 earthquakes in 30 days, the most in a single month in the entire 42-year record. Alex Iezzi, a geophysicist at the United States Geological Survey Cascades Volcano Observatory, put it plainly. She said the run of quakes had piqued our attention. The quakes seemed to be coming from below the center of the mountain. Seemed, because with a single station, the observatory could not be sure how deep or exactly where. In late September and into October of 2024, crews moved fast. They set a temporary ground sensor at a trailhead and planned 2 more nearby, trying to build enough coverage to catch the smaller shocks the one station kept missing. It did not stop in September. From September of 2024 through January of 2025, the observatory counted roughly 12 small earthquakes at the volcano. The largest was that magnitude 2.0. Then, sometime in the winter, the shaking faded and the mountain went quiet again. As of the summer of 2026, Mount Adams sits at green, the normal alert level, quiet and calm. But the version you have heard, that a volcano rumbled and then settled back down, is not the full picture, because of what happened in between. When those quakes started, the observatory realized how blind it actually was. One permanent station, 7 miles from the summit, cannot pin down a small earthquake. It cannot tell you if the quake is 2 miles down or 10. So the scientists did something that tells you how seriously they took it. They started pulling people and gear off another volcano. That other volcano is Glacier Peak, one of the most dangerous in the state. A peak the United States rates far higher for threat than Adams. Crews had planned to put in key sensors there. Instead, they delayed Glacier Peak by 2 years and moved the work over to Mount Adams. They rushed in temporary monitoring stations to try to catch the smaller quakes the single station was missing. Some of those temporary stations have since been removed or buried under snow. A permanent network of 5 new stations is on the way, with permits already cleared for 4 of them. Each of those 5 stations is meant to work like a tripwire. Ground sensors to feel the shaking. Sound sensors to hear the low rumble a moving wall of mud makes. Global positioning system, receivers to catch the ground shifting. Wire them into a county alert system and, in theory, the valley gets a signal the moment a flow starts. In theory, the instruments still have to be built and bolted down. The alerts still have to be routed to the right phones. And the people living in the channel still have to know what to do when the phone buzzes. But putting the sensors in the dirt is only the beginning. Sit with that for a second. Adams was never supposed to be the problem, and the people whose job is watching cascade volcanoes decided it could not wait. Now drop down and look at where this mountain actually sits. Mount Adams stands 12,277 feet in the south-central Cascades of Washington, about 50 miles west-southwest of Yakima and 30 miles north of the Columbia River, on the edge of the Yakima Nation. It is the tallest point in a huge volcanic field of more than 120 smaller volcanoes spread across 4 counties. One number matters more than the rest. Over the past million years, Mount Adams has produced roughly 300 cubic kilometers of rock, more erupted rock than any other cone-shaped volcano in the Cascade Range except Mount Shasta. By size and by volume, it is the largest active volcano in Washington. Not the tallest, that is, Rainier, the largest. And it has been sitting there, mostly ignored, for a very long time. The last eruption was somewhere between 3,800 and 7,600 years ago. The Yakima people call the mountain Pato. It carries more than 10 glaciers on its slopes, rivers of ice that feed the creeks running off every side of it. And despite being brushed aside for decades as the sleepy giant next to flashier neighbors, the United States rates its threat level as high. Rainier is about 45 miles to the north. Mount St. Helens, the one everybody remembers, is about 35 miles to the west. Adams sits between them, taller than St. Helens, wider than either, and studied far less than both. Ignored is the key word, because the danger at Mount Adams was never really about lava. To understand the real threat, you have to understand what is happening to the rock near the top of the mountain. For thousands of years, hot and cold water has moved through the summit rock, breaking down the minerals, weakening the rock from the inside. It has slowly turned solid volcanic stone into something soft and crumbling. United States Geological Survey scientists have a plain name for the result. They call it rotten rock. Think of a wooden beam that still looks like a beam from the outside but has gone soft and rotten on the inside, the kind that holds its shape right up until weight lands on it and it gives way all at once. That is the state of the upper cone of the largest volcano in Washington. Ground surveys have mapped as much as 1.3 billion cubic meters of this weakened, water-soaked rock in the southwest part of the summit. That is 46 billion cubic feet of rock sitting high on a steep slope, held in place by nothing but gravity and habit. The glaciers are part of why that rotten rock is so dangerous. Weakened stone, soaked with water and loaded with ice above it, is the exact recipe for a slab that breaks free and turns to mud on the way down. And unlike its violent neighbors, Mount Adams is not a very explosive volcano. When it has erupted, it has mostly put out lava flows and ash, not the kind of blast that tore the top off Mount St. Helens. That is the quiet trap of this mountain. People watch for the eruption that probably is not coming and miss the landslide that has already come twice. And it does not need an eruption to move. An earthquake can loosen it. Wearing away can loosen it. Heavy rain or fast snowmelt can loosen it. When a big enough piece lets go, it becomes a huge landslide of loose rock. And a landslide like that on an ice-covered volcano almost always turns into a lahar. A lahar has nothing to do with lava. Picture a fast, wet landslide, a mix of mud, rock, ash, and melted glacier ice that moves and acts like flowing concrete. In a narrow river valley, it often runs 20 to 35 miles an hour, and on a steep upper slope, it can pass 120 miles an hour before the ground flattens out. It picks up trees, boulders, and bridges as it goes, and it can grow to more than 10 times the size it started. It arrives like a flash flood with almost no warning, and it buries whatever is in the channel. The channel, in this case, is the White Salmon River. It runs off the southwest slope of Mount Adams, straight down past the towns in the hazard zone. Trout Lake first, then BZ Corner and Husum, then the town of White Salmon near the Columbia. Ben Pauk, a geophysicist at the Cascades Volcano Observatory leading the monitoring project, has said a lahar off that slope could travel down the White Salmon Valley and reach Trout Lake in about 20 minutes. 20 minutes. That is the entire warning window for a town of 672 people whose county emergency plan, until recently, did not even have a section on lahars. And 20 minutes is the best case. The sensors sit miles from the summit, so the clock only starts once the flow is already well on its way. By the time an alert clears the valley, the real window is shorter still. If you are finding this useful, subscribe. We break down one Cascade volcano, fault, or water system every week, with the full picture and the real numbers you need to actually follow what is happening under your feet. By the fall of 2024, That quiet blind spot on the map had become the observatory's problem to solve. And the closer you look at the hazard, the worse the math gets. Because this has happened before, more than once, and the ground around Trout Lake is the receipt. About 6,000 years ago, a huge lahar came off the southwest side of Mount Adams and roared down the White Salmon Valley. It traveled about 35 miles. In places, it left layers as thick as 65 feet. It raised the floor of the river so much that it dammed a smaller stream and made a new body of water. That body of water is the lake that Trout Lake is named after. The whole town is built on top of that old mudflow. Then, only about 300 years ago, it happened again. A landslide off the weakened summit sent another lahar down toward Trout Lake, scattering blocks the size of houses across the valley floor. People who live there today mow their lawns around boulders that a broken-off piece of the mountain dropped in their yards. Each of those two big flows, 6,000 and 300 years ago, began as a huge landslide of loose rock that swept across more than 30 square kilometers of ground south of the volcano. Smaller collapses came again in 1921 and in 1987. Those only traveled a few miles. The mountain has been shedding pieces of itself, on and off, for as long as anyone has been able to read the rocks. This is the mountain's normal behavior, stretched over more time than any town can remember. So the question the September earthquakes raised was never really, is Mount Adams about to erupt? The answer to that is almost certainly no, not soon. The real question is quieter and harder. Is the mountain getting less steady? And with one monitoring station, nobody could answer it. The danger spreads from the top of the mountain down to the river. First, the wilderness. The upper slopes of Mount Adams are climbing routes and fields of ice inside a protected wilderness area. And the south climb up the southwest side draws people every summer, straight across the same weak, water-soaked ground that has failed before. A collapse or a steam blast begins exactly where those climbers stand, high on the mountain, with no road and no fast way down. Second, Trout Lake. 672 residents, dairy farms, herb farms, the closest town to the mountain, 14 miles from the summit and right in the White Salmon Channel. On the current models, this is the town with about 20 minutes. Third, the valley below it. Beezy Corner and Hewsome sit downstream on the same river, and the town of White Salmon, home to a couple thousand people, sits near where the White Salmon meets the Columbia. A large enough flow does not stop at Trout Lake. It keeps going toward the gorge. Fourth, the county and the plan that was not ready. Trout Lake is in Klickitat County, and as recently as a couple of years ago, the county emergency plan had no lahar section at all, for a valley that geologists know has been hit twice. Jeff King, the county's emergency management director, has admitted that how they would respond is something officials are still working out. In February of 2025, local, tribal, state, and federal officials finally met to rewrite the Mount Adams and Mount St. Helens response plan, which had not been updated since 2014. Fifth, the river itself, all the way to the Columbia. A lahar that reaches the Columbia, or even just dumps enough mud into the streams that feed it, could choke the Columbia River shipping channel, one of the most important farm shipping routes in the area. The east side of the mountain has its own smaller mass of weak rock, about 12.5 million cubic meters, hanging above the Klickitat River Canyon, a second, lower chance path for the same kind of event. None of this needs the volcano to erupt. That is the part that is hard to hold in your head. We are taught to watch for smoke and lava. The thing that has actually reached the towns and taken lives below volcanoes like this one is mud. In 1985, a volcano in Colombia called Nevado del Ruiz sent a lahar down that reached the town of Armero, about 45 miles downstream and out of sight of the mountain. More than 20,000 people were lost. Most of them never saw the volcano that buried their town. The lahar came in the dark, down a river valley, exactly the way one would come down the White Salmon. Closer to home, the last big lahar in this area came off Mount St. Helens in 1980. More than 2 billion cubic yards of mud and rock buried the upper 17 miles of the North Fork Toutle River Valley. That is how big these flows get when a Cascade volcano lets go. John Major, the scientist in charge of the Cascades Volcano Observatory, has said there is no imminent threat at Mount Adams that anyone is aware of right now. In the same breath, he has said that does not mean it could not happen tomorrow. Both of those sentences are true at once. That is the whole problem with this mountain. The hazard is real. The odds in any given year are low, and the warning time is short. The observatory puts real numbers on those odds. The yearly chance of a lahar large enough to reach the Trout Lake area is put at 0.1 to 1%. For a truly disastrous one, the size of the flow 6,000 years ago, it is 0.01 to 0.1%. Small numbers. But they are yearly, they never reset to zero, and they sit on top of a town with a 20-minute head start and, until this year, no plan. In just a few months, Mount Adams went from a mountain almost nobody in the hazard business worried about to a volcano with its own emergency planning effort, its own rushed sensors, and its own place near the top of the observatory's list. Nothing about the rock changed in those months. What changed is that 6 small earthquakes made everyone look, and once they looked, they saw how little they could actually see. The mountain did not get more dangerous in September of 2024. People just finally started measuring the danger that was already there. So, the open questions stack up, and none of them have clean answers yet. Why did a mountain that gets about 1 earthquake every 2 to 3 years produce 6 in a single month, then go quiet? Were those quakes just the ground settling, or the first sign the rotten rock is loosening? How do you warn a town of 672 people in the 20 minutes it takes for a wall of mud to come down a river they cannot see the top of? And how many other Cascade volcanoes are sitting under a single station, blind in exactly the same way Adams was? Right now, the snow is back on the summit of Mount Adams. It covers the temporary sensors. It covers the loose rock. It covers the scar where the mountain last let go 300 years ago. Down in the valley, the White Salmon River runs south past the dairy farms of Trout Lake, the way it has run for 6,000 years, over the buried layers of the last flow that came through. And 14 miles up, above the town, above the snow line, that mass of soft, rotten rock is still sitting there in the cold, held in place by gravity, waiting. The one station that can hear it is still listening, and it still cannot tell you whether this is nothing or the start of something.